Thank you. Don't have a lot of time, so we're going to get right into the population of greater sage grouse that I've been studying for the last 2 years. The population I'm looking at is in southwestern Utah. It primarily occupies BLM land, and it is on the fringe of the greater sage grouse species distribution range-wide. It also, being on the fringe of a population distribution of a population in decline, it may be under more threat of extinction than more centralized populations. In addition, being on the fringe, it may be that these birds are occupying habitats that are marginal as compared to other parts of the distribution, and so the birds themselves may have developed habitat preferences that are unique. In addition to the pressures of just being on the fringe, this area of Utah has really high potential for renewable energy development. The Utah Renewable Energy Zones Task Force made zones for wind, solar, and geothermal energy potential. And you can see there's significant overlap with the study area. Now, these areas aren't designated to be developed, but they show high potential for resources, and being on BLM land, there's definite potential for energy development in this area. So my thesis objectives are to first determine what the migration patterns, seasonal distributions, and seasonal home ranges are for this population. This population has never previously been studied, so it's important just to get some baseline information before proceeding. And the next step is to determine vegetation characteristics of what the birds are using in this area, and also what habitat characteristics are available in the study area. And then finally, what I'll be talking about today is a species distribution model for this population. So we radio collared a bunch of sage grouse and tracked them over 2 summer seasons, getting weekly locations, and 1 winter season, getting monthly locations. We also used aerial telemetry, and we did not use aerial telemetry locations in our analysis. We really used the aerial telemetry to help find missing birds and search for birds that might have gone outside of the study area. We used the program Maximum Entropy to create 3 models per season, and also for a nest and brood. And the summer and winter seasons, our cutoff dates were guided by other literature for other populations in the initial modeling that we've done. Our variables we examined were at a 30-meter resolution, and to start we looked at 11 relevant variables for this population. And right into the results. So for our summer species distribution model, you can see the red is high probability of presence and blue is low probability of presence, and the black dots are actual telemetry locations. So you can see the model is starting to do a decent job of predicting where sage grouse are. There's still some problems that we need to address. For example, there's some points here that they're bird locations, but they're not showing up as any probability of presence in the model. There's also some points down here, as well as up in this area, where points actually go outside of the study area. So we weren't able to train or test the model on those data points. What's really exciting about this modeling program is that we can use local specific management techniques and fire regimes. For example, here you can see fire year came up as one of the variables of significance in this model. And this area in here where there's bird clustering is clearly a response to the year that that fire occurred. So this model has the ability to give land managers some really specific guidelines on what the birds are preferring. And then if we look at the top predictor in this model, the distance to nearest lek as the highest contributor, we can actually break it down and examine what the effect is. And so this is another good tool for management. For example, looking at the core area strategy as a management tool and if that would be affected for this population. So it's really interesting to note here there's a really distinct mark. So my x-axis here is the distance to LEC in meters. The y-axis is the probability of presence. And you can see this really distinct cutoff at 5 kilometers where the probability of presence farther than 5 kilometers is really unlikely. Now onto the winter data. This model's also starting to come together, but we still have a couple of issues. There's an area down here and an area up here where there's some bird clustering, but it doesn't show up as strongly in the model as we would hope. But if you see again, the distance to nearest LEC is our top predictor. So this could essentially mean that the model is accurate and that there are LECs on the landscapes that have not yet been identified. So it'd be really important to ground truth these in the future and see if maybe there's a LEC here, and if there is a LEC there, we put it in the model, and I'm pretty sure that would be a significant hotspot. Another thing I'd like to point out, although it was a lower predictor in this model, is habitat treatment type. The BLM provided me some information about fuels treatments that they've done in the area, and I could actually incorporate these in the model so that we could later look at how birds are using habitat treatment types that the BLM has implemented. And then once again, we'll just show you the distance to nearest LEC response, and you can see that for the winter data, the threshold by which birds are not found in proximity to the LEC is a little bit higher, about 7 kilometers from a LEC. And I'll just say that for both of these models, the distance to LEC is not necessarily the LEC that the bird strutted at. It's just any LEC that's on the landscape. So I also did a nest and brood model that I'm still working on. I don't have time to get into that today, but I just want to emphasize that the reason that this modeling is so important for this population is that we can now see that the overlap is going to be significant, and we can use this information to guide management for the future for development. So what we're going to do with the model moving forward is use the telemetry data to better inform the model. We're going to use seasonal cutoff dates from the telemetry data to account for those birds that maybe are in a migration state. And then we're also going to adjust our study area to account for the birds that were located outside of the study area. We're going to add a couple more variables to see if they improve our model. And then once we create our final model for the study area, we're going to actually project it to the larger BLM Cedar City office. We'll be able to ground truth that with some independent telemetry data that another grad student has been collecting. And then, as I mentioned, we can look for new LECs as a ground truthing method as well. And then we'll be able to really make recommendations based on the life histories of this specific population and also the bird's response to individual model parameters. Now, the title of this talk is Unique Habitat, and I just want to quickly and briefly mention that the birds that I'm studying have been found to use juniper, which is not normal for sage grouse. And so I've had over 35 locations of birds that were radio collared found roosting under or near juniper. This GPS unit right here, that's where a fecal pile was found. So I'm trying to address if this population has other unique habitat preferences, and I'm trying to look at that with my species distribution model. So if I project my species distribution model to a population that's more central in the population, then I can compare telemetry points to my model, and if they don't match up, then potentially my model is overfit. Otherwise, it could mean that there are actual differences on the landscape that this population is selecting for. And with that, I'd like to thank my funding sources and my committee members and a bunch of volunteers, and maybe I have time for a question.
Are you looking at any existing infrastructure on the landscape that influences distribution at all?
Yeah, in one of the models, I've already looked at things like distance to road and distance to water source. I'm still working on a habitat layer for distance to existing transmission lines and pipelines and that type of infrastructure. I'd also like to include in that the year that it was put in, so I can see if there's maybe a time effect as well. So all these models are definitely ongoing, and that is something I would like to look at. Thank you.